Welcome to this presentation on Introduction to Microwave Engineering. We'll explore the fascinating world of high-frequency electromagnetic waves and their applications. Microwave engineering focuses on electromagnetic waves with frequencies ranging from 3 to 300 GHz. These high frequencies result in wavelengths that are much smaller than the components used in traditional circuits. This makes standard circuit theory inadequate, and we need to rely on Maxwell's equations to understand the behavior of these waves. Microwave engineering has a wide range of applications, from our everyday lives to advanced technologies. Wireless communication systems, radar, medical imaging, and remote sensing are just a few examples. The high frequencies of microwaves offer several advantages. They allow for greater antenna gain, larger bandwidths, and line-of-sight propagation, which are crucial for various applications. Additionally, microwave frequencies interact with molecules in unique ways, leading to applications in medicine and remote sensing. The foundations of microwave engineering were laid by James Clerk Maxwell in 1873, followed by the experimental validation by Heinrich Hertz in the late 19th century. The development of radar during World War II significantly advanced the field, leading to a surge in research and applications. Microwave engineering is a dynamic field with continuous advancements and expanding applications. From our smartphones to advanced scientific research, microwaves play a vital role in shaping our world. Thank you for your time. I hope this presentation provided a valuable introduction to the fascinating world of microwave engineering.